In this problem, we're given an array A of length n. Let's call a subarray good if it's of length at least 3 and the XOR of the start and the endpoints of the subarray equals to the sum of the elements in between them. We're meant to calculate the total number of good subarrays. Let's take an element and set it to be the left endpoint of the subarray. Let's also assume that the maximum bit that's set in that element, k, is the maximum bit of the XOR of the start and endpoints of the subarrays. Therefore, we know that the sum in between the start and endpoints of the subarrays can't be greater than or equal to 2 to the power of k plus 1. This is because the XOR has to only consist of bits less than the k plus first bit. Therefore, we can keep shifting a pointer to the right until the sum is greater than or equal to 2 to the power of k plus 1. All valid pairs for the end of the subarray must lie in between this range. Anything further to the right will have a sum greater than or equal to 2 to the power of k plus 1, which contradicts our earlier assumption of the maximum bit of the XOR being equal to k. We can then reverse the array and do the same thing, this time assuming that each element is the endpoint rather than the start point. This is the same as setting the endpoint and shifting a pointer to the left while the sum is less than 2 to the power of k plus 1 without reversing the array. At first glance, this might seem to be O of n squared if we do it for each element, but it's not. Let's mark all the positions in our array where the maximum bit set is equal to 2 to the power of 30 with an x. For a particular position, we can't visit more than one other position with 2 to the power of 30 set. This is because if we visit more than one such position, the sum ends up being greater than or equal to 2 to the power of 31, which means that no further XOR pairs can be in our range. Therefore, each element gets visited a maximum of 2 times. However, since we reverse the array and repeat the process, each element gets visited a maximum of 4 times in total for each bit. Now note that we can break the ranges for bits less than 2 to the power of 30 into even smaller segments. These segments can't cross positions which have the 2 to the power of 30 bit set, as that would mean that the sum is greater than or equal to 2 to the power of 30. Hence, the final complexity ends up being O of n log max of ai with a small constant factor. A small thing to note is that we'll have to keep track of the pairs we've already counted, as we may end up revisiting pairs in the same range when we reverse the array. So that's how you solve problem E. I have video editorials for A, B, C, D and F too, so check them out if you're interested. I'll also be posting more videos like this in the future. If you enjoyed the video, please like, share and subscribe.